stumbled across the term confidence interval. That's probably why you're here. So today we want to talk about some details and make the whole concept more understandable. Hello and welcome back to the channel. So first, a quick definition as always. So confidence intervals are an interval that includes a specific value with a certain degree of confidence. Well, what does this mean? So if you're estimating data, you can never be 100% sure that this data is correct because it's only an estimate. And therefore, we use confidence intervals to measure how likely it is that a specific value falls between those that were defined as the confidence interval. And you determine your confidence level by the so-called alpha value, which is actually a threshold. So if you set your alpha to, for example, 0.05, this means that the likelihood of the fact that your finding is pure coincidence is lower than 5%. Here you see a visual depiction of it. This is a two-tailed test, which means that you're looking at the upper and lower levels. It's also possible just to say, well, you only want to have bigger values and you have a one-tailed test. If you want to know more about that, and especially normal distribution, there's a separate video linked above. Now, a confidence interval, so is the mean of the estimate and the variation around that estimate. And now, when you repeat an experiment, you expect a specific proportion of the values to lie within the boundaries of this interval. That's the whole point. You can calculate confidence intervals for population means, also means between groups, estimating variation, and also for proportions. Again, as those are intervals and not points, they're also a useful measure for the variation around the respective values. So if you have a big confidence interval, this means that there's great variation within your data set. Now, actually, confidence intervals are not calculated by hand, as most statistical programs can do that. But if you're still in school or also at university, and in general to understand the principle behind it, it's still useful to, well, let's think about how we would calculate it. First, you need an estimate, obviously, which is the number and can be, for example, the population mean. Then you have to find the critical value, which is the number of standard deviations that you have to be away from your value to reach the confidence level you want. Here it's also important to consider alpha values and whether it's a one or two tailed tests, and then there are tables to find the correct values. When we're talking about Z statistics, which are true for normal distribution, then we have a value of 1.64 for a 68% confidence interval, 1.96 for a 95% confidence interval, and 2.57 for a 99.5% confidence interval. Then if you have a normal distribution, you can use this formula to calculate the confidence interval, which is not that difficult. We have the mean, the standard deviation here, and total number of samples. If your data is not normally distributed, you might want to find another distribution which fits your data, or it's also possible to transform your data. And even though transformations are not uncommon, you mustn't forget to transform it back when you're taking a look at the upper and lower bounds of your confidence interval. Now, let's say we have a 95% one, which is actually pretty standard. This means that the probability of what one wants to calculate is 95% that the value is between plus and minus 1 standard deviation. But this also means that there is a 5% chance that the value lies outside of the interval. Therefore, you have to be cautious because you don't, especially when we're talking about population means, you don't know the real population mean, and therefore there's still this 5% chance that what you're getting is wrong, even though this chance is minor. So nevertheless, confidence intervals are commonly used in various research disciplines. And another important aspect is that the accuracy of your outcome not only depends on those statistical measures and techniques, but especially on your research methods, just to say that. This was a quick overview. If you want to take a look at the video about normal distribution or the t-tests, they are also linked. And yes, if you enjoyed this video, don't forget to give it a thumbs up and to subscribe to the channel to see weekly uploads on various scientific topics. See you in the next video.